Okay, these are our 1.2.4 notes. So I'm going to title those as such. And the focus on this is on graphing linear inequalities. So to get started, let's review graphing inequalities in general. So we'll do two problems. So if we have 2x plus 4 is greater than 20, and then we'll do negative 3x minus 6 is greater than or equal to 24. And let's just graph these on a number line. So to be able to graph these inequalities, we obviously need to solve for the missing variable, or solve for x. So in this case, we subtract 4 from both sides, and we'll get 2x is greater than 16. Then divide both sides by 2, and we get x is greater than 8. So on our number line, if we call this 8, 7, 9, and so on, we know our values have to be greater than 8. So we put a circle at 8, and then we draw our arrow to the right, because it's all values greater. Next, we need to decide whether we fill in the circle or leave it open. If it's greater than, but not equal to, you leave that circle open like so. If it's greater than or equal to, like the one below, you gotta shade it in. For here, same idea. Let's add 6 to both sides. So we get 30 there. Divide both sides by negative 3. Oh, with an inequality, when you're dividing or multiplying by a negative, remember you gotta flip that sign. So 30 divided by 3 is negative 10. And we have x is less than or equal to negative 10. So let's put negative 10 there, so that would mean negative 10 to the left, negative 9 to the right. And it's everything less than negative 10, so that's everything to the left. And we fill it in, because it's including negative 10. Okay. The focus for today is on graphing linear inequalities, not just one variable inequalities. So let's get into it. So our goal here, our example, is to graph y is greater than 3x plus 4. So let's draw a coordinate plane, roughly. When you're graphing linear inequalities, there are a few different steps we take. Number one is we graph the line. So we can imagine this is y equals 3x plus 4, so we're going to graph it like we would graph that. So that means our y-intercept is at 4, and our slope is 3, meaning we go up 1, 2, 3, over to the right 1. Up 1, 2, 3, over to the right 1. And the same would follow for the opposite direction. Okay. However, when you're graphing linear inequalities, there are a couple different types of lines. So our second step is determine the type of line. So with linear inequalities, when it is just greater than or just less than, we have a dashed line. So it's like the equivalent of an open circle that we saw above. This dashed line means it's not including the points on that line. That's why it's greater than, but not equal to. And the next part is we need to determine the type of shade. So when we're drawing our inequalities up here, it either includes or doesn't include the point, and then it's everything to the left or everything to the right. When we're graphing linear inequalities, it's either includes the points in the lines or not, and then it's either everything above the line or below. If it's greater than, we shade above the line. If it's less than, we would shade below. So let's kind of summarize these different types of inequality signs. So let's make a table here. So we'll have our inequality signs. Let's focus on the type of shade and then the type of line. Okay, so there are 4 different types of inequalities. There's greater than, there's less than, there's greater than or equal to, and then there's less than or equal to. So when we are greater than, you shade above. So notice it's not left or right, it's above or below. And when it's just greater than, we have a dashed line because it's not including the points in the line. When it's less than, we would shade below. And again, we would have a dashed line because it's not including the points on the line. When it's greater than or equal to, so greater than again means above. But since it is or equal to, that means you include the points on the line. So you would draw a solid line. When it's less than or equal to, you shade below. And you would also have a solid line because of that or equal to part. So notice, when it has greater than, it's above. When it's less than, it's below. If it is or equal to, it's solid. If it's not, it's dashed. Okay. So for our next problem here, let's use this table here. And let's describe the shade type, so both the line and the shade, for some different problems. So we're not going to do any graphing here. I just want you to determine what type of line and what type of shade we have. Okay. So for each of these problems, pause the video and quick determine the line and shade. Okay, we're back. So here, it is greater than but not equal to, so we should have a dashed line. It is greater than, so we should shade above. Here, it is less than or equal to, so that or equal to part tells us we should have a solid line. But because of that less than, we should shade below. Over here, we are less than but not equal to, so it's a dashed line. Less than means below. And last one, we are greater than or equal to, which means we should have, because of that or equal to, a solid line. And because it's greater than, we shade above. Okay. So that summarizes how we determine shading and lines. You want to keep that in mind now as we do some practice problems. So here we're going to practice some graphing. So we have a few different problems here. So what I'd like you to do for number 1, we're going to graph y is less than or equal to negative 2/5 x plus 3. And then I'll put number 2 up here if you want to work ahead of me. 5x, y is less than 5x minus 3. So again, when we're graphing these, and we'll start with number 1, start by graphing just a regular line. So this is a linear function. It's got a y-intercept of 3, so 1, 2, 3. Its slope is negative 2/5. That means the rise is negative 2, the run is 5. So we go down 2 over 1, 2, 3, 4, 5. Down 1, 2 over 1, 2, 3, 4, 5. Over here, we would go in the opposite direction, so up 2 over 1, 2, 3, 4, 5. Okay, I feel pretty good about that. Now we look at the inequality. So it is less than or equal to, so that means we should have a solid line. And since it is less than, we shade below. So just do some light shading. And there we have it. That's our linear inequality. Okay. Number 2. So we have y is less than 5x minus 3. So again, we start by just graphing this function. So y-intercept at -3, slope is 5, so that means we go up 1, 2, 3, 4, 5 over 1. Up 1, 2, 3, 4, 5 over 1. Okay, 3 points should be enough. We are less than, not equal to, so we should have a dashed line. And since we are less than, we shade below the line. So notice again, not left and right, it's always above and below. Okay. All right, let's do a few more here. So let's do y is less than or equal to 5x plus 1, and negative 10x plus 2y is greater than negative 8. And for each of these, in addition to graphing, what I'd like you to do is identify some different pieces for these functions or inequalities. So I want you to identify the slope, the line type, the shade type, and then lastly, is the point 0, 0 a solution? So, let's see. So we'll just graph below here. So this kind of walks through each of our steps that we take. So as we look at this linear inequality, the y-intercept is 1, and that's where we'll be starting. The slope is 5, so that means our next point will be up 5 over 1, because it's a rise of 5 and a run of 1. 1, 2, 3, 4, 5 over 1. Okay? From there, since it is less than or equal to, so that or equal to part tells us we should have a solid line. It is less than or equal to, which means we should be shading below. Last question here, is 0, 0 a solution? So for a point to be a solution to a linear inequality, it has to exist within the shaded region. So whether that is on the line, if it's a solid line, or in the shaded area. So as I look at 0, 0, that's right here, that is in the shaded region, so we would say yes. Another way you can determine is 0, 0 solution is algebraically. So 0, 0 is just a point. If it's a solution, it should fulfill this inequality. So if we plug in 0 for x and 0 for y, the inequality should stand true, which it will. It'll show that 1 is greater than or equal to 0, or 0 is less than or equal to 1. Okay. For number 4, let's find those same values. So we want our slope, which I'll just call m, our y-intercept, b, our line type, our shade type, and is 0, 0 a solution? And again, we'll also want to graph here. Okay, so from here, notice we can't figure out our slope and y-intercept because this is not in slope-intercept form. So we got to switch it. So that means we should add 10x to both sides to get that y alone. So I will fit that over here on the right. So that'll leave us with 2y is greater than 10x minus 8. Then to get y by itself, we divide everything by 2. So we'll get y is greater than 5x minus 4. So if your inequality is not in slope-intercept form, you got to get it there. So from here, y-intercept is -4. Slope is 5 again. We seem to like using 5 as a slope. So let's graph this line. So it starts at -4 on the y-axis, then has a slope of 5. So we go up 5 over 1. Up 1, 2, 3, 4, 5 over 1. Okay, 3 points is enough. It is greater than, not equal to, so we should have a dashed line. And our shade, since it's greater than, will be above. So let's look at 0, 0 solution. It's right there. It's in the shaded part. The answer would be yes. Okay. So another thing to mention is what about the reverse? So what if I have a linear inequality and I want to write the function? So let's say I'm drawing this inequality. Like so. And I want to check and see if that, see what is that linear inequality. So first I notice our shade here is below. Our line type is solid. So when I'm writing my inequality, I know I'll have y is less than because of below and or equal to because of solid. And then it's just a matter of determining what's my slope, what's my y-intercept. Well, the y-intercept is at -4. The slope, I notice we go up 1, 2, 3, 4, 5 over 1. So the slope is 5, so we'd have 5x minus 4. So when you are finding a linear inequality from the graph, if you need to write it, look for the shade, the line type, the y-intercept, and the slope, and you should be able to find it. Okay. That concludes our lesson for 1, 2, 4. Have a great day.